Hello everyone. Today we are going to see different types of modeling used in Verilog. There are three types of modeling, in which first is a behavioral modeling. So and next is a data flow modeling, and third is gate level modeling. So first we'll see a behavioral modeling and what are the timings used in behavioral modeling. So behavioral models contains procedural statement which control the simulation and manipulate variables of the data type. Now here behavioral model consists of different statements. They are called procedural statements, and they are used to simulate and manipulate the variables. Whatever the data type you have used, so they are used to simulate it and manipulate that variables. Then these statements are contained within the procedures. So all the statement used in behavioral modeling, there are different statements which used in behavioral modeling. So they are within the procedures, and each procedure has an activity flow associated with it. So it has each statement or procedure have its own flow. During the behavioral model simulation, all the flow defined by the always and initial statement start together at simulation time 0. So here, whenever we use behavioral modeling, we have to use two statement, or we can say that two keywords, that is always and initial. So here always and initial are the compulsory statement and keywords used in behavioral modeling, which starts with the zero simulation time. That means it do not require any simulation time, just they are used in behavioral modeling, that always and initial, it is a compulsory statements. Next, initial statement are executed once, but always statement are repeatedly. So initial are always executed once, and always are executed repeatedly. So this is the just one example of behavioral modeling. Here module, or we know that what Verilog start with the module and end with the end module. So here module behave. Now what is behave? Behave is nothing but your name given to your circuit diagram. This depends upon you. So I just give this behave because we are using this behavioral modeling. So I have given the behave name. You can give any name. Now I do not know the terminal list, so I have not mentioned here terminal list. I have just defined the name of that module. Then register one is to have to use data type register, and for the register data type we have one keyword, that is reg. So you have to use reg for storing the input output. So in behavioral modeling, always it stores in register. So register 1:0 ab. Now here ab are vectors. We have seen this, what is the meaning of this particular bracket, that is a vector. So that means a is a 2-bit number, a0 a1, and b is also 2-bit number, a0 a1. Now initial. Now this is one statement which is compulsory in behavioral modeling. Initial means we have to initialize the variables, which variable we have used, a and b. So a b, we have to initialize a and b. I have to give the value to a b, like I have to initialize it. So we have to use initial. This is the statement initial, and initial statement starts with begin and end with end. So these two keywords are used in any statement. Any statement is start with begin and end. Like in C programming, we used like for loop. When we used loops like for, and then whatever the statement or here expressions are there for loop, and we start with the curly brackets, like this brackets. So here in Verilog, it do not start with this brackets. It starts with begin and end with the end. These two keywords are used, begin keyword and end keywords. Now I have to initialize a and b. So I have given a is equals to 1. Here a become 1 and b is 0. Now I have initialized a and b, a as 1 and b as 0. Now end with the end of this initial statements. So begin and now always. Now this is other conditions. Now always, again it starts with begin and end with end keywords. Now hashtag hash 50a, which is equals to summation of a. Now this is a delay or timing, we can say that timing, or what is the hash 50 meaning of this, like 50 seconds. So it generates the 50-second delay. Now after 50 seconds, in version of a will be stored in a. So after 50 seconds, inversion of a, not of a. So if here a is 1, now after 50 seconds a become 0. So this is the meaning of this particular always statement. Next always statement, then again it starts with begin and end with the end keyword. And here after 100 second, inversion of b will stored in b. So after 100 second, inversion of b is stored in. This is one example how to write the code. So what we have just initialized the variables a and b, and then after some time a will become 0, and after some time b will become inversion of b will stored in here b. So it starts with all begin and end. Then end of the I want to end my programming, so it starts with module and end with the end module. So this is how the behavioral modeling works. So it always starts with initial, and then always statements are compulsory used in behavioral modeling, and it is compulsory to store the variables in register. So register data type is used in behavioral modeling, and behavioral modeling is mostly used for sequential circuits. Next, delay assignments. Now there are two types or three types of delays. So first is delayed assignment. So here delta t time units passes before the statement is executed, and then the left hand side assignment is made. Now here how delayed assignment is worked. So first, whatever the statement is there, that execute time is passed before the statement is executed. So first the delay is called, and then the statement is executed, and after the execution of that statement, it is stored in the left hand side of assignment. Like here in this here we have used, this is the left hand side assignment. So first delay is called, and then it gets stored in b. This is called delayed assignment. And then intra delay assignment. In intra assignment delay, the right side is evaluated immediately. Whatever the hand side expression is there, it evaluated immediately. But when we call for result, then for result it calls the delay. So it calls delay for making result or for displaying it in the left hand side assignment. So this is the difference between delay assignment and intra-delay assignments. So syntax of this statement: first a procedure assignment variable which is equals to expression, and how to call the delay. This is the simple assignment, that procedure, whatever the assignment variable is there, which is equals to the expression, and how to call the delay. So for a delayed assignment, first we have to take the hash, whatever the value delta t means here timing 50 second, 100 second, whatever the value you want to give that. So delta t variable, that is equals to expression. This is the way of defining delay assignment. And for intra assignment delay, first variable, that is equals to, after the equals to sign, we have to define the timing, that hash delta t, whatever the timing 150, and then expression. So this is the way of defining intra assignment. So in delayed assignment, first statement is executed, and then the delay is called. And here first the right hand side is evaluated first, and then for result it shows some time, whatever the time is there, result will be displayed. Next, blocking assignments. So what are the blocking assignments? A blocking procedural assignment statement. Statement means like we have used the initial and always, so they are the statements. So in blocking assignment, the procedural assignment will be must be executed before the execution the statement that follows in a sequential block. So here first whatever the assignment is there, that executed first before the sequential blocks. Syntax for this calling the blocking assignment: first one value, which is equals to timing control, and then expression. Now what is this first one value? One value is nothing but the data type, whatever the data type you are using, like register, net, wire. So the data type here, I uh, one value is nothing but the data type used in the statements. Then equal to sign, this sign shows blocking assignment, it is the operator of blocking assignment. Then timing control, whatever the timing you have to give that hash 50, hash 100, expression, whatever the expression is, that right hand side value which is equals to the left hand side. So expression, you have to write the expression. And in non-blocking, or it is also called as RTL assignments, in non-blocking assignment, first it follows the procedure, whatever the flow is there. Like we have written one code, suppose, and the flow, it follows that flow, one statement two, statement three, it follows this flow, and for result it will call the delay, that is called as non-blocking assignment. And the syntax, just there is one difference, that instead of equal to sign we have to use less than or equals to sign for non-blocking assignments. And similarly, one value is nothing but data types. This operator is nothing but a non-blocking operator, used for non-blocking assignments. Then timing control, delay, what the value of delay, hash, and the value of delay, and then expression, like left hand side and right hand side, whatever the expressions are there, you have to write that expression. For blocking, it will first execute and follow the first execute before the following the steps. And in non-blocking, it follow the steps, and after all steps done, they call the delay. Next are the case statements. So what are the case statements? The case statement is unique multi-way decision statement that tests whether an expression matches several other expressions and branches accordingly. Now here in case statement, what is that? It is a decision making statement. So this case statement is useful for describing, for example, the decoding of microprocessor instructions. Syntax for a case statement. First, case case statements start with the case keyword and end with the end case keyword. This keywords we have to use this keyword, like case, CASE, and then expression, whatever the expressions are there, you have to write that expression. And then case items, like case 1, case 2, case 3, how many cases are there. So case 1, case 2, case 3, case 4, case 5, up to whatever number of items are there, case, and then end with the end case. So this is the syntax for making the case statement. Like next, if we want to use impedance in case, so we have to use case Z means impedance, and if the items are unknown, then we have to use case X, like unknown, for unknown value. Next, looping statement. Now in Verilog there are 4 types of looping statement. First is forever loop, second is repeat loop, third is while loop, and next is for loop. So forever, first is forever loop, and forever loop, it is used for continuously execute a statement. If I want to continuously execute one statement, so I will use forever loop. Like a statement or any value, suppose I have connected one LED to one terminal. This is my LED, and I have connected it to terminal A, and the another terminal is grounded, and I want to on this LED continuously. Now this is the, just we are using for the symbol purpose, like for danger purpose. For danger, the red light is on, so I want to use this LED, red LED, continuously on. So I will use this forever loop. So forever A will become, A should be 1 forever. So continuously this LED will be on. So here in this manner forever loop will work, like for when we want continuous execution of particular statement. Next, repeat. Now I want to repeat this, I want to give alternatively on and off this particular LED. Like for first time it should be on, another time it should be off, then after some time it should be on, off, on, off, on, off. I want to repeat this several times, like 10 times I want to on and off this LED, or 100 times I want to on and off this particular LED. At that time I will use this repeat loop, so that for fixed number like 100 times, 10 times, repeat this particular value a is equals to 1 and b a is equals to 0 for 10 times. So here I will use repeat loop. Then while loop, when I want to use several conditions, like if a is equals to b, then only c will be 1. Suppose a is equals to 1. Okay, so while a is equals to 1, then only c will become 1, otherwise it will be 0. So while is nothing but when we want that one expression, and till the expression is true, it will it will execute that particular loop, and when the expression becomes false, then it will exit that particular loop. So while loop is used for expression, like when a is equals to b, then only c should be 1, and when a is equals to, suppose, b, so till a is equals to b, and the value of a will be equals to b, then c will become 1. And if the statement become false, if a is equals to is not equals to b, then it will exit that particular loop. So here while loop work in such a manner. And for loop, so for loop, we know that for loop execute associated with 3 steps, the variables. We have used a and b, two variables. So just for loop, we have to give the value that a is equals to 1 or b is equals to 1. So for, I will use a is equals to 1. That means this is nothing but initialization. Then semicolon, and after in next step, what is evaluate the expression, whatever the expression is there, like a is equals to, a less than equals to b, or a is greater than equals to b, a is equals to b, is not equals to b, whatever the expressions are there, that will be here. Here will be the expression. Suppose I will write a when a is greater than, until the a is greater than b. So perform this particular task unless the a greater than b. Next, in the second step, suppose a result becomes 0, then it will exit, and if it is not equals to matlab 0 or whatever the conditions are there, so it continues to the third step. And third step is normally modify the loop controls variable value, like it repeats or it increments, like a plus plus and b plus plus. The value of a will be incremented or decremented, depends upon the conditions. So this is the way of defining for loop. This is the syntax for loops statement, forever loop statement, whatever the statement you want. For the next way, this is the one way, and the another way, it starts with begin and end with and keyword. So when you can use begin and end keywords, or else you just directly write the statement. So this is the two ways. All loops have two ways to define, with begin and end or without begin and end. So here, then repeat the express state. This is statement, you want to repeat this statement for whatever the expressions are there, means how many times you want to repeat this particular statement. So you have to write that expression here. So repeat expression and then statement. This statement, I want to repeat this statement 10 times, 1,000 times, or any expression, like if it is equals to if the b, then I want to repeat till the a is equals to b. So here that expression will be there. And then another way, repeat expression with, before writing the statement you have to write begin, and after a statement you have to write the end keywords. Then while, again for while also, while bracket expressions, whatever expressions are there, like a is equals to b, a is not equals to b, a is greater than b, or a is equals to 0, while statements and then statement. So work this statement until that expression becomes false. Then another way, again, while expression, before writing a statement you have to write begin and end. Next, for loop. So in for loop assignment, whatever assignment like assignments data type a whatever the initialization steps in assignments, you have to write the initialization. A is equals to 1, b is equals to 0, whatever the assignments are there. Then expression, and then assignments. Assignments means increment or decrement. Then statement. And another way, before writing statement, you have to write begin and end with the end. So this is the way of defining the loops. So there are 4 types of loop: forever, repeat, while, and for loop. Next, data flow modeling. Now in data flow modeling make use of functions that define the working of circuit instead of its gate structure. Now in data flow modeling, it defines the working, or how the circuit will work. It defines that. This modeling allows the designer to focus on optimizing the circuit in terms of flow of data. Now here the designer focus on the how the circuit will work, and this is the flow from input to output. So here it describes the hardware in terms of input to output. The data flow modeling style is mainly used to describe the combinational circuits. Now data flow modeling is mostly used in combinational circuits. So now half adder, full adder, mux, demux, this all are the combinational circuits. So we have to use data flow modeling for this combinational circuits, and for sequential circuit we have to use behavioral modeling. So here data flow modeling use continuous assignment and keyword assign. Now in data flow modeling, we have to write the Boolean expression. We know that in combinational circuit we write Boolean expressions. Whatever the output are there, we write the expression for that output. So in data flow modeling, we have to describe that Boolean expression by using assign keyword. Here behavioral modeling, we use always an initial keywords. Here we use assign keywords. And a continuous statement is a statement that assign a value to a net. Now here net type of data type used in data flow modeling. So the data type net is used Verilog HDL to represent a physical connection between circuit elements. Syntax, assign left hand side net is equals to right hand side. How to write the data flow modeling, we will see one example. Module ABC XYZ. Now here what is module ABC is a name of your circuit. You can write any name, like you can give my circuit, my design, or if you are using combinational circuit like half adder, full adder, so you can write here half adder, full adder, mux, demux, any name you can give any name. So I have just mentioned A B C. This is my one circuit which having name A B C. So this is my circuit. Now I know there are 3 terminals X, Y, Z. Now I do not know which one is input and which one is output. So I have to define which one is input and which one is output. So here X, Y are 2 inputs and Z is one output. Now I know X, Y are 2 inputs. This is my X, this is my Y. They are input and Z is output, X and Y. So this is X, Y. There are 2 inputs and Z is output. Now I have to define. I have defined this X, Y, Z terminals, which is input and output. Now I have to perform the expression. What is the expression? Now my output will be summation of inputs, like Z will be X plus Y. So I have to add these 2 inputs and I have to store in stored in output like Z. So Z is equals to X plus Y. So how to write Z is equals to X plus Y? This is the expression, and that expression is used with assign. So this is the keyword which is used in data flow modeling. Whatever the expression is there, you have to use assign, and then the expression will be back. And this is the expression, Z is equals to X plus Y. So this is my expression, Z is equals to X plus Y. So summation of my input will be output. So here assign Z is equals to X plus Y. If I want to subtract X minus Y, so I will write here assign Z is equals to X minus y. If I want to multiply them, so I will write assign z is equals to x, multiply ka symbol, what is multiply symbol of multiplication, into x into y. So in this manner we used data flow modeling, and here module starts with module and end with end module. So just in data flow modeling, we have to write the expression by using one keyword assign. So assign, and then whatever the expression is there, you have to write that expression. Next, gate level modeling. In Verilog HDL supports built-in primitive gates modeling. So the gate supports are multiple input, multiple output, tri-stage, and pull gates. The multiple input gates supported are AND, NAND, OR, NOR, XOR, and XNOR, whose number of inputs are two or more but has only one output. What do you mean by multiple inputs? That means it can have two or more input but only one output. Next is multiple output gates. So they support buff and not. They have one more than one output and only one input. And they are tri-state gates, which includes buff if 0, buff if 1, not if 0, and not if 1. These gates have one input, one control signal, and one output. This buff if 0, buff if 1, not if 0, and not if 1 have one input and one output and one control signal. And then the pull gate supported pull up and pull down with only one output, but there will be no input. Syntax, first we have to use these keywords for gate level modeling: and, NAND, OR, NOR, XNOR, XOR. These are the keywords. Then buff, not, buff if 0, buff if 1, not if 1, not if 0. These all are symbols, sorry, keywords. Next, single input gate. Not and buff are single input gates. So they have only one scalar input but can have multiple output. So buff stands for buffer, and transfer the value from input to output without any changes in polarity. And not get stands for inverting the polarity. Suppose here one input is there, A is one input, and Y1 is suppose not get. Not means simply not get, and buff, that is Y2. So buff is nothing but transfer the value from input to output without changing polarity, means as it is. If zero will be if A will be 0, then for not it will invert, it will become 1, and for buffer it is as it is passing 0 to 0. And if A is 1, then not will invert it will become 0, and for buffer it will be 1 only. So passing the uh, input from output as it is without changing the polarity. So that is buffer. So these are the one input but can have many output. So how to define this module? Gates. Now I have given this gates name of that my module is gate, and here I have mentioned in terminal list only that is my input and C is output. So buffer C A. Now first we have to write output and then we have to write input. So here C is output and A is B is not there. So here A is my input. Now buffer A. Suppose A is 0, so it will in C it will store 0, and if A is 1, then in C also it will become 1 only, because it is buffer. Buffer means as it is. And not DA. Now if A is 0, so in D it will store 1, and if A is 1, then in D it will store 0. It will get inverted. So and then end with end module. So module gates, whatever the terminal list, you can write it as A, C, D, and then again you have to define it, which one is input, which one is output. So instead of making that two step, I have mentioned here only that A is input and C D is output. So here buffer C, first we have to write the output and then we have to write the input. So this is the not and buffer gate. Next, multiple input gates. So in multiple input gates and or XORs, these three are gates which is having multiple input and have only one output. So this is the example module and or XOR. All three together I am writing and or XOR gates. This is my name of my gates or my circuit, my design, and or XOR gate. And here C, D, E are output and AB is input. And C, A, B. Now here AB are two inputs, and in C the ending of AB will be stored. So here it will be nothing but AND gate, like A, B, my two inputs, like it can be 0, 0, 0, 1, then 1, 0, and then 1, 1. So here C means ending of this A and B. So it will become 0, then 0, 1 becomes 0, 1, 0 becomes 0. And if A and B are 1, then it will become 1. So here in this manner, and gate will work. So and first output, I want to store the ending of AB in C. So I will write here C and then input AB. So C is output and AB are two inputs. Next, similar manner, you can write OR and XOR. Just write, we have to write the keyword OR. This is for OR gate, or then D, AB. Now ORing of A and B will store in D. So here I will write D, which will be ORing of AB. So A plus B, that is 0, 0 or 0, that is 0, 0, 1, 1, 1, 0, 1, and then 1. So this is nothing but OR gate. Then in similar manner, XOR. Here XOR, XOR, this is the keyword which is used for XOR gate. So XOR and E will be the output. So XORing of A and B will stored in E. So E is output, A and B are two inputs, and then end with end module. So this is the gate level modeling. Next, NAND, NOR, and XNOR gate. They are multiple inputs. They can have multiple inputs. So here in similar manner we can write, so just we have to write the keywords of that particular gates. So here NAND gate, NOR gate, XNOR gate. Here again output C, D, E, these three are output and A, B are input. So NAND, AB. Now and NANDing of A and B will stored in C. Here C is output, AB is input, then NOR, XNOR. So similar manner we have defined the different gates. These are the keywords XNOR, NOR, and NAND, and end with end module. So I hope you have understood what are the different level of modeling: behavioral modeling, gate level modeling, and data flow modeling. In behavioral modeling, we have to use initial and always statement, and whatever the input and output are there, we have to compulsory stored in the register type data type. So we have to use reg keyword for storing that register input output in the registers, and initial and always statements are used. Then there are different timings, delay, there are blocking assignment, non-blocking assignments. Then in data flow modeling, we have to write the expression by using the assign keywords. Whatever the expressions are there, we have to define that expressions in a symbol, and we have to use the different symbols. We have seen the operators, different operators in Verilog, like for addition, ending, nanding, nor which type of operator is used. So we have already seen that symbols and how to use that operators and how the operators will work. So in expressions, we have to, in data flow modeling, we have to describe that hardware in terms of expressions by using the assign keyword. And in gate level modeling, just we have to use the different gates and the keywords of gate. We have already seen what are the keywords of gate, and this in gate level modeling, it defines by the different gates and the connections of that gates. So I hope you have understood.